A question says, a load is to be moved using a wheelbarrow. The total mass of the load and the wheelbarrow is 60 kg. The gravitational field strength is 10 newtons per kg. What is the size of the force F needed just to lift the loaded? So, how do we find this force? So, you might recall that this is coming from the what? The moment, the turning effect of the force. So we have the force F and the weight. Remember that the total mass is 60. That means the wheelbarrow and the load, they all have a weight of. So weight, you know that weight is equal to mass multiplied by gravity. So the mass is 60, gravity is 10, so the weight is 600 newtons. That is the W that we need. So this weight is acting here at the center, W. Okay? The weight is always acting at the center of an object. So this is where our weight is. So, what else do we need to have? We need to have the distance traveled by the weight from the pivot. That is the distance from where the weight is all the way to the pivot, because this is where it is turning from. They have written it the pivot, right? And we also need the distance of the force F from the pivot. So from here to here. Then we are going to use principles of moment, because we have this force, this force going up, so it's going in this direction, while this one is going in this other direction. So you have the clockwise and the anti-clockwise. And according to the principles of moment, anti-clockwise should be equal to clockwise moments. So clockwise, which one do we have as clockwise? Clockwise, so our weight multiplied by its distance from the pivot should be equal to the force multiplied by its distance from the pivot. So now, what is the weight? 600. The distance of the weight from the pivot is 70. You can put 70 centimeters, there's no problem. You don't have to convert the distances. Here the force F will remain, and the distance we have here is 50 plus 70, because we're moving all the way from there up to there. So we get what? 120. So here over 120 and over 120. So our F is 42,000 over 120, which will just end up giving us the force as 350 newtons. We've seen how we can use the principles of moment to work out real life problems. So our answer is A. Simple and straightforward. Please subscribe. You can also start your online classes, quite affordable.